The idea of going to Mars, which is going to be done at some point, it may not be done in the next few years, but it's going to be done. Mars is a trip that takes a couple of years. And we're getting fairly close to having the rocket technology to get there and back and to land on the moon or on Mars and everything. What we're not really close to at this point is understanding what effect this will have on the astronauts. So we really need to understand that so that we can manage the risks for these people. Radiation effects on atherosclerosis are really important in a lot of cases. For instance, occupational exposure. When people don't have the proper shielding, they get a little bit too much exposure. One of the first things that happens, or one of the most important things that happens to them, is years later they have problems with heart disease. So we know about that. We know that cancer patients are susceptible to heart disease after they've been irradiated. Radiation primarily comes from the stars, including our own sun. Our sun puts out mostly protons, a lot of X-rays and things like that. The really large ions come from other stars further away.
What we asked was if we target specific parts of the arteries in these mice to cosmic radiation, do we see an acceleration of atherosclerosis? The findings were particularly dramatic because a single dose of radiation had long-lasting, appeared irreversible effects on the artery wall. Plaque development was accelerated. There seemed to be more cell death within the plaque. The plaques generally appeared morphologically, so by composition, more advanced, all consistent with a dramatic acceleration of plaque development. So this is the impact of this is extremely important because we know now, and this is the first study of its kind, to show that the kind of radiation encountered in space can significantly increase risk for heart disease in the human population.
All of the biological research that NASA does is applicable to something on Earth. So ours is relevant to things like therapeutic radiation. Right now, we have no strategy as to what to do about a heart that's been irradiated unavoidably. What we would like to develop out of this project, since the astronauts really can't avoid the radiation, is develop strategies for what are you going to do after you've been irradiated to prevent the damage from occurring, or to at least mitigate the damage. That there are new types of therapeutic radiation coming out now. We don't know what they do. We haven't had enough experience with them to know what kind of damaging effects they have. And we'll learn a lot about that from this NASA project.